Hello friends, today we are going to study about the continuation of protein purification methods. In the last video, we studied about salting out and various types of chromatographic methods that can be used for the purification of protein, utilizing different properties of protein. Today we'll start with electrophoresis. Electrophoresis separates molecule according to charge and size. The term electrophoresis means electro means electricity and phoresis means movement. So it's the movement of charged molecules in the presence of electric field. With electrophoresis, we can separate the charged molecules. In general, how it works, we have to prepare one gel which will have its particular pore size. It should be connected with an electric field having one negative end and one positive terminal. Suppose the molecules are negatively charged. So we will have wells here. We'll load our sample in the cathode side so that they will start migrating towards positive end. Depending upon the size, they will get separated. Suppose we have two categories of molecules, small size and large size. Both are having same charge. The small size molecule will move faster and the large size molecule will move slower. So that's how a small size molecule can get separated from a large size molecule. After we get the band, we can visualize these bands by various methods. Either we can go for staining or we can use autoradiography. If our protein is radiolabeled, then we can use this method. Or we can go with immunoblotting. If our protein is an antibody, then we can make it react with an antigen, and that's how we can analyze the protein. Or we can go with Western blotting. So after getting the bands which denotes different proteins, we can visualize these bands using these four methods. So this is in basic about electrophoresis. Now for protein, we use SDS-PAGE. What is PAGE? Polyacrylamide gel electrophoresis. What is SDS? Sodium dodecyl sulfate. Now what is the function of this SDS? It has two functions. One, it denatures protein by disrupting hydrophobic interaction. And second, it imparts negative charge to the protein. So suppose we have a mixture of proteins. Because of this SDS, now all the protein will have the negative charge. So they can move in a gel from negative end to positive end. Now, as because all the proteins have negative charge, the separation will purely based on molecular mass. As because sodium dodecyl sulfate denature protein by disrupting hydrophobic interaction. Now, the proteins having multiple subunits. These subunits or the polypeptide chains remain associated with each other either through covalent interaction or through non-covalent interaction. This we already studied in the last videos. Hydrophobic interaction is a type of a non-covalent interaction. So if the protein subunits are associated with each other through hydrophobic interaction, all the subunits will get separated. So in SDS-PAGE, we can able to get the molecular mass of individual subunits of a particular protein. So using SDS-PAGE, we can not only separate the protein, even we can separate and tell the molecular mass of individual subunit of a protein. Now, what if the polypeptides in a protein are connected through covalent interaction? That is a disulfide bond. In that case, we need to use a reducing agent, that is 2-mercaptoethanol. If our protein consists of more than one polypeptide chains which are associated through non-covalent interaction, they can get disrupted due to SDS. If it contains polypeptide associated through covalent interaction, then in that case, we have to run the SDS-PAGE using this reducing agent 2-mercaptoethanol. This reagent will disrupt the disulfide bond and the subunits will get separated. Next is capillary electrophoresis. Capillary electrophoresis means when the electrophoresis is carried out in a thin capillary tube of diameter 20 to 100 mm. Now, what is the advantage of carrying out electrophoresis in such a thin tube? Normally, when electrophoresis is performed, because electric field is used and electricity generates heat. So because of that, in electrophoresis, we use buffer. So heating will evaporate those buffer, resulting in poor separation or poor output of the electrophoresis. So carrying out electrophoresis in such a thin capillary tube will dissipate heat rapidly, due to which we can carry out the electrophoresis at high electric field as well. And because of this high electric field, the separation will become fast. So it can reduce the separation time. In normal electrophoresis, we cannot perform electrophoresis in very high electric field because it will generate heat and that heat will affect the process of electrophoresis. Whereas in capillary electrophoresis, the heat dissipates rapidly, due to which we can carry out the electrophoresis at very high electric field, reducing the separation time. Other advantages are high resolution. The process can be automated, and one disadvantage is because only less sample can be used. So this method can only be used for analytical purpose. Isoelectric focusing. What is isoelectric focusing? Every protein will have their respective pI. What is pI? pI is that pH when net charge is 0. How we can get this pI? We already studied in the last videos. When the pH is very low, that time the predominant form of amino acid or a protein will be fully protonated form. If we raise the pH further, what will happen? The carboxyl terminal will lose proton. If we raise it further, what will happen? The amino terminal will also lose the proton. So at very low pH, the predominant form is this positively charged form. At very high pH, the predominant form is this negatively charged amino acid or protein. In some midpoint, the predominant form is the zwitterion form, having both the negative as well as the positive charge. This pH is known as pI because the net charge will become 0 and protein or amino acid will not move in the presence of an electric field. So isoelectric focusing means if we carry out electrophoresis in a gel or in a solution having a pH gradient, that means from anode to cathode side, the pH will smoothly increase because a gradient is prepared. And now if we load our proteins and carry out the electrophoresis, the proteins will start moving depending upon the compositions of amino acids present. Every protein will have different pI, a different point at which it will perform as a zwitterion and get separated from each other. This is known as isoelectric focusing. Now, in 2D gel electrophoresis, we combine isoelectric focusing with SDS-PAGE. What we do is, first in horizontal direction, we perform isoelectric focusing so that the proteins will get separated based on their pI. Now, in this direction, we'll perform SDS-PAGE so that now the protein subunits will also get separated. So 2D gel electrophoresis. Why? Because 2D, because we are performing isoelectric focusing, perpendicular to which we are performing SDS-PAGE. So this is a very powerful tool in proteomics. In a single gel, we can separate even 5,000 proteins. So it's a very powerful technique for the separation, characterization, and analysis of protein molecules. Next is ultracentrifugation. Now here, the proteins are get separated based on their mass. Centrifugation, that means we rotate the macromolecules at a very high speed so that the gravitational force increases over those particles and they get settled down. The rate at which a particle will sediment in an ultracentrifuge is related to its mass. But the relation is not very linear. Sedimentation coefficient of protein range between 1s to 50s. What is S? This is Swedberg, the scientist who discovered centrifugation. The sedimentation coefficient of viruses, it ranges between 40s to 1000s. So in ultracentrifugation, we rotate the complex mixture of proteins at a very high speed so that they get settled down based on their mass. The proteins with large mass will settle down first compared to the protein with lesser mass. So that's how ultracentrifugation works. Now that's all about purification methods that are used for purification of any protein. Now, as I said earlier, that for any protein, there is no such standardized method that this one method you have to follow and your protein will get purified. It's a trial and error process and you have to perform multiple purification steps to purify your protein. Now, how to know that further purification steps are not needed to purify a protein, or how you can know that your protein is now completely pure and further purification step will not increase the protein purity. So for that, first we need to know two terms. One is activity, one is specific activity. Activity means total unit of enzyme in a solution. Specific activity means number of enzyme unit per mg of total protein. It helps to measure the purity of protein. You can understand it in a very simple way, like activity means the total activity of total proteins. Specific activity means if a mixture of protein is present, so activity is the overall activity of that mixture of protein. Specific activity means from that mixture of protein, it is the activity of your desired protein which you want to purify. So we have to perform purification steps that will enhance the specific activity because we want desired protein. So as we go on purifying the protein, the specific activity will go on increasing. When we have to stop, when further purification will not enhance the specific activity. When a point is reached, when further purification step is not enhancing the specific activity, that means now your enzyme or protein is completely pure. For example, 5 purification steps. We have different parameters like fraction volume in ml, total protein in mg, activity in units, and specific activity in units per mg. Now, as the purification step proceeds, suppose we have a mixture of protein. First, we are purifying with step 1. The output which we get will use that output again for step 2. The output will use for step 3, then step 4, then step 5. Like that, we are purifying the protein. Suppose this is the fraction volume. So what will happen if we go on purifying the protein? The fraction volume will go on decreasing. Why? Because the unwanted proteins are getting eliminated. What will happen to total protein? It will also go on decreasing. Why? Because if we have a mixture of 10 proteins and among that 10 proteins, we want one protein. So by each purification step, we are removing the other proteins. So definitely the total protein amount will also go on decreasing. What will happen to the activity? The activity will also go on decreasing because the total protein or enzyme is getting eliminated. What will happen to specific activity? The specific activity will go on increasing because now our protein is getting concentrated with our desired protein. It is not now the mixture of protein, it is the one single desired protein. So in every step, we are eliminating the unwanted proteins, because of which the specific activity is go on increasing. When the further increase, say for example, we are using step 6 also. But after using step 6, the result is same. No further increase in specific activity. That means we should stop our purification process up to by 5 only. There is no need of further purification. So that's how we can know when to stop our purification process. In a successful step, the loss of non-specific protein is always greater than loss of activity. So the specific activity should always increase, though the total activities go on decreasing. So that's all about protein purification. Now, one question from my end for you all, that is, determine the subunit composition of a protein from the following information. Here, some informations are given. Using these informations, you have to tell me the subunit composition of a protein. So we have a protein and we performed gel filtration. We obtained molecular mass of 200 kilodalton. Then the same protein is analyzed using SDS-PAGE. There we got the molecular mass of 100 kilodalton. When the SDS-PAGE is performed using 2 mercaptoethanol, so we got 40 kilodalton and 60 kilodalton of band. Now you have to determine the subunit composition of a protein. So now, using these information, let me know in the comment section the subunit composition of a protein. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.